My research topic is pre-service teachers' conceptualizations of mathematical tasks. The focus of the study is the way that mathematics pre-service teachers select and describe the characteristics of mathematical tasks and teachers' abilities to select and implement tasks that are accessible for their students is a part of their pedagogical content knowledge, and the way that mathematics pre-service teachers or teachers in general describe characteristics of mathematical tasks and the factors that they highlight in their descriptions would help us to analyze their abilities to select and implement tasks. That's why the focus of this study is a part of teachers' pedagogical content knowledge. I have drawn my argument on how do mathematics pre-service teachers or pre-service teachers in general build their capacities or abilities for selecting appropriate tasks for their students. So I have articulated my argument based on the um, literature that have discussed different kind of instructional activities and the influence of those activities in building teachers pedagogical content knowledge and teachers selection and descriptions of mathematical tasks in particular. So Crispo 2015 and Crispo and Since 2008 they have shown that instructional activity, for example, whole class discussion about what makes an interesting problem, would influence teachers' way of describing characteristics of mathematical tasks. And also there are some studies that have suggested that teachers who have been exposed to literature related to pedagogical content knowledge and who have exposed in related reflective activities develop their pedagogical content knowledge. So based on these studies, I have included instructional activities in my studies. Those instructional activities include solving mathematical tasks, reading and reflecting on literature related to mathematical tasks, participating in small and large group discussion, performing task sorting activities. Task sorting activity means the activity where teachers or pre-service teachers have to categorize tasks based on some framework and selecting tasks and describing the characteristics of tasks. So my research question is, after mathematics pre-service teachers have had opportunities to engage in instructional activities, so these are the instructional activities related to mathematical tasks, how do they select tasks and describe the characteristics of such tasks? So I have my conceptual framework. I have two extant conceptual framework and readings, and based on these four sources, I have seen the commonalities in these four sources and drawn five categories of tasks, and I have used these categories to report my findings and to analyze my data. The context of the study is 12 mathematics pre-service teachers enrolled in a teacher education program at a large Midwestern universities enrolled in participated in the study, and I facilitated those instructional activities that I described earlier as an instructor. At the moment of data collection, mathematics pre-service teachers were preparing to student teach the following semester. So basically, they did not have formal teaching experience at the moment of the data collection. And I am looking the whole class as a case. So I did not analyze the individual mathematics pre-service teachers' way of describing characteristics of mathematical tasks. Rather, I focused on like whole class as a case, and I analyze like whole data as a unit. And these are the series of instructional activities, and I am not going to describe all of these. These are the descriptions of the activities that I described earlier in my slide, but I am going to describe the data point. First one is first data point came from mathematics pre-service teachers answers to the questionnaire related to the two tasks. So basically at first, mathematics pre-service teachers solved 2 tasks, and then they reflected on their experience with task solving, and they were asked to select one of the tasks, and they were asked to provide justifications for their selection, and these answers were, or their reflection was a data point, and the other data point was the end of the was at the end of the series of the activities. So mathematics pre-service teachers were asked to find or construct a high school mathematical task and provide the justification for their selection or construction of that task. So this data point helped me, I compared this data point to report my finding. So I basically compared how mathematics pre-service teachers describe or selected characteristics of mathematical tasks at the beginning and at the end of the series of the activities. So I reported my findings like based on the framework that I had, that I described earlier. So in terms of connected tasks, mathematics pre-service teachers produce a broad set of descriptors after they engaged in the instructional activities. So these are the codes that emerge from the initial data point, and these are the codes then that they emerge from the final data point. So we can see same sets of codes that emerge from both data set, but we can see more codes that emerge from the final data point. So they had more ways to describe connected tasks at the end of the series of those instructional activities. And the other factor is mathematics pre-service teachers started considering student related factors while describing connected tasks. For example, they said, okay, this task is connected task because it helps to connect students prior knowledge and current knowledge. That's why I would consider this task as a connected task. And in terms of challenging task, also mathematics pre-service teachers produce a broad set of descriptors, but we can see here like a different code that emerges from initial code, which is not emerged from final data set, that is length of task. I'll describe it later. And we can see like more codes that emerge from final data, and they those mathematics pre-service teachers started to emphasize student related factors while describing challenging tasks. Basically they said our task is challenging or not is not something we can say absolutely, because it depends on different student related factors. For example, student pre-knowledge or age, and those kind of factors. For example, they said this is one of the codes that I have put here from their responses. They said the cognitive demand is out of reach of the lowest student and is still reach for those that understand the concept already. So when they said lowest level, it was kind of a little bit confusing, but I could say they were focusing on student factor. But when they said those that understand the concept clearly, I can say they were focusing on the students pre-knowledge to describe to mention challenging task, because cognitive demand of task help us to categorize and to analyze the task if that is challenging for students or not. And in terms of open and engaging tasks, also they produce a broad set of descriptors. In terms of feasible tasks, they did not mention anything about feasibility of tasks at the beginning of the activities. Basically, these are the codes that describe feasibility of tasks. So if the task is doable in school and for homework, if this is developmentally appropriate for students, for example, this is appropriate for high school student, or this is appropriate for middle school student, and if the task can be solved by using available instructional material, if the task is technologically accessible or not. These are the descriptors that I have in my conceptual framework to describe feasible tasks, and these are the same descriptors that mathematics pre-service teachers highlighted at the end of the series of the activities, and which is not mentioned in their initial responses. So based on those course and categories, I came up with some major themes. First one is length of task versus feasibility. So as I mentioned at the beginning of the activities, they focused on length of task to describe difficulty level of task. Basically, they said, I did in my head, I did not really take any judgment, I just did it, it was mental math. But at the end of the activities, rather than focusing on length, their attention shifted towards feasibility, as I mentioned. So they started focusing on students who have a very strong understanding or student who struggle. So basically they started focusing on student pre-knowledge, their age, so early algebra geometry level. So it can be done within on the constant of time limit of classroom. They focused on this factor. And the other main theme was informal versus formal. So at the beginning of the activities, the language that they used, they means mathematics pre-service teachers used, was more informal. They said the task was much more in depth, it was more straightforward, less straightforward, and um, more thinking, etc. So but at the end of the activities, they used more formal language that was informed by the literature. So they use the language such as procedure without connection, procedure with connection. They use these words or phrases like more correctly actually. So in the discussion, I can see the shift, but I did not record their discussion in the class, and I cannot like really say their attention shift was because of these instructional activities explicitly, but based on the literature that I discussed in my literature review section, I can claim that, I can argue that this kind of attention shift was because of these activities. So I have discussed those studies. They have claimed that mathematics pre-service teachers' way of describing characteristics of mathematical tasks is influenced by classroom discussion, influenced by the literature, influenced by the reflection on literature. So I have um, discussed that this kind of, and or concluded that these kind of activities, instructional activities, are helpful for pre-service teachers as they start to highlight different kind of factors that would be helpful for them to implement mathematical tasks later when they actually start their teaching. Yeah, thank you so much.